So today we are teaching you the chemistry of acetone. To introduce ourselves, my name is Cari Liang and
my name is Dinh. To begin with, acetone is used for many purposes that many people don't know. You could use acetone to remove old ink stains like the one right here, to remove nail polish, and to clean up makeup tools. Shiny.
acetone. Great solvent for melting polystyrene, which is the material that's made from styrofoam. Polystyrene dissolves in acetone well because it's made out of carbon-hydrogen bonds, and acetone can dissolve carbon-hydrogen bonds very well. As shown in this chart, it's partially nonpolar because the whole structure is mainly symmetrical, but the oxygen has lone pairs, so it's considered polar. The nonpolar polystyrene can dissolve in nonpolar acetone since nonpolar substances can dissolve in nonpolar solvents, so styrofoam cannot dissolve in water since it's polar. To demonstrate, I will start off by pouring a little bit of acetone into this container and try to dissolve this whole cup in the acetone. Let's start.
Wow!
We will now compare the intermolecular forces of acetone and compare it to control group, which is water. Shown right here, hydrogen likes to have fun, F-O-N. In the molecule shown here, the hydrogen H is not connected to any F, O, or N, which is fluorine, oxygen, and nitrogen. So there's no hydrogen bonding. As you can see, there's dipole-dipole forces and London dispersion forces. Water has hydrogen bonding. It is having fun, F-O-N, because oxygen is connected to hydrogen in the molecule. Hydrogen bonding is technically the strongest intermolecular force, excluding ion dipole bonding. Since acetone has weak ion mass, the bonds break easier, meaning it will evaporate quicker. Hydrogen bonding, on the other hand, is more difficult to break, which is why the boiling point of water is so high compared to acetone. The boiling point of acetone is 56 degrees Celsius, while the boiling point of water is 100 degrees Celsius. Since acetone has weak intermolecular forces, the bonds break easier, meaning it will evaporate quicker. Hydrogen bonding, which is in water, on the other hand, is more difficult to break, which is why the boiling point of water is so high compared to acetone. The boiling point of acetone is 56 degrees Celsius, and I'll put 2 drops right here, while the boiling point of water is 100 degrees Celsius, and I'll put it on the bottom. As you can see, acetone has evaporated faster, much faster than water.
For the final experiment, we will do the combustion of acetone. We will figure out if it is spontaneous, but first we have to find delta H and delta S. Delta H tells us if it is releasing energy or if it's absorbing energy. And delta S will tell us if it is becoming more disordered or less disordered. To find the delta H of the combustion of acetone, first you have to figure out all the bonds that are in the reaction. First you can see that there is a CH bond in the reaction and the energy is 410, and there's 6 CH bonds, 1, 2, 3, 4, 5, 6, which is why I multiplied 410 by 6. Next, we see that there's 2 CC bonds, and each CC bond is 350, which is why I multiplied it by 2. And there's 1 CO bond, and the CO bond is 732, and there's only 1, so that's why I added by 732, and I didn't multiply it by anything. The next one, you see that there's a double O, and the double O is 498, but we multiplied it by 4 because there's a coefficient of 4 up here. And we would do the same thing on the product side. After you find the energies for both sides, we use the equation of delta H, which is reactants minus products. So you would do 5,884 minus 7,152. Then the delta H would be negative 1,268 kilojoules per mole. And this would mean that the reaction is releasing heat because there's a negative sign over here. Next, we have to find the delta S of the reaction. First, you have to find the standard entropy values of the reactants and the products. And you can find these values online. So you see that the equation is products minus reactants. So we should look at the product side first. We see that there's CO2 and H2O. So CO2 is 213.8. And then we multiply that value by 3 because there's 3 CO2 in the product side. Next, you see that there is H2O, and each H2O is 188.8. And you multiply that by 3 also, because there's a coefficient of 3 over here. And then you do the same thing for the reactant side. Then you do products minus reactants, and you should get about 93.95. And since it is positive, it will be more disordered. Next, we plug in all the values to find Gibbs free energy. First, we look at delta H, which is negative 1,268 kilojoules per mole. Then you subtract that by temperature and delta S. The temperature at standard room temperature is 25 degrees Celsius, but you add 273 to convert it to kelvins. Then you plug in delta S, which is 93.95. Then you should get a final value of negative 29,265.10 kilojoules per mole. And as you can see down here, when delta H is negative and delta S is positive, delta G should also be negative, and our calculations are correct, which means that it is spontaneous.
So we start 10 grams of acetone because that would be how much we'll burn. And I found the molar mass of acetone, which is 58.0321 to 1 mole of acetone. And then we looked at mole ratio. So 1 mole of acetone will produce 3 moles of CO2 because the equation of 1 mole, 3. And then we have to cancel out the moles, so 1 mole of CO2 will have 44.01 grams of CO2. You cancel everything out, solve, and the answer will be 22.8 grams of CO2 gas. Down here, everything will be the same, except we will be looking at H2O, so the answer will be 9.32 grams of H2O gas. And I also want to point out that oxygen is the excess reactant species literally all around us. The acetone is the limiting reactant because it will eventually evaporate and disappear into the atmosphere.
Here we have about 10 grams of acetone, and it's surrounded by a bowl of water, just in case if it cracks, because then fire will go everywhere. So like my assistant said earlier, acetone is the limiting reactant, so when it runs out, the reaction will stop. And it's producing CO2 and H2O gas. You won't be able to see it, but I can illustrate it and show you how. So let's do it. So the bag has no air inside, so let me tumble it. You can see here, the bag is filling up with something. It's filling up with CO2 and H2O gas. Look, it's flying. Ta-da!
Thank you guys for watching, and I hope you guys learned something new.
Have a nice day.